Good morning, students. In the last class, we discussed about Kirchhoff's laws and Wheatstone's bridge. Today, we are going to discuss comparison of EMFs of two cells by using potentiometer. We are going to compare the EMF of two cells by using potentiometer. So, the statement of potentiometer is the potential difference across the length of the potentiometer wire is directly proportional to its length. The potential difference across the length of the potentiometer wire is directly proportional to its length. For example, just consider these are the two wires. It's a small wire, it's a large wire. Now, the potential difference across its length, that means the potential difference in between this end and this end here. So, the potential difference in between the ends of the wire is directly proportional to its length, the length between two ends. Similarly, here also, the potential difference across its length, that means the potential difference between its end points is directly proportional to its length. So that is the statement of the potentiometer. That means depending on the length of the wire, we can find out the potential difference. So if the length is small, the potential difference across its length is also small. If the length is large, then the potential difference at the ends of the wire is large. That means the potential difference of the potential difference at the ends of the wire depends on its length. The potential difference at the ends of the wire, that means across its length, is directly proportional to its length. So that is the statement of the potentiometer. So potential difference, that is B, is directly proportional to its length L. So potential difference is directly proportional to its length. The potential difference across the length of the wire or potential difference at the ends of the wire is directly proportional to its length. So based on this statement, we are going to compare the EMFs of two given cells. EMF means the abbreviation of EMF is electromotive force. Electromotive force, EMF. It is represented by epsilon. So electromotive force, it consisting of the force, but it is not a force. It is a potential difference. EMF is a potential difference. So the definition is EMF is potential difference between positive and negative electrodes in a circuit when no current is flowing through the cell. So potential difference between what? Positive and negative electrodes in the circuit when no current is flowing through the cell. For example, if you consider a small circuit consisting of a cell or battery, so one side positive terminal, other side negative terminal. So when no current is flowing through the circuit, then the potential difference between the positive and the negative electrodes is nothing but EMF, electromotive force. Potential difference between positive and negative electrodes in the circuit when no current is flowing through the cell. So based on these things, we are going to compare the EMF of two cells. So this is the experimental arrangement. So this arrangement consisting of two diagrams. One is a primary circuit or primary diagram, and second one is secondary circuit or secondary diagram. So the primary circuit consisting of a battery or a cell B and a rheostat means it is a variable resistor. The difference between resistor and the rheostat is resistor has fixed value while rheostat has variable. It can be varied. We can change the resistance of that resistor. It is a variable resistor. It is not a fixed. We can change from one value to another value. Whereas resistor, it always fixed. Its value is fixed. So resistor has fixed value. Rheostat has variable resistor. Its value can be varied. So the difference in the symbols is, so this one represents resistor fixed value. Rheostat means same as resistor but arrow mark like this. So this arrow mark indicates that it's a variable resistor, rheostat, and this is called key. Key means it acts as a on-off switch, and from A to C. So this is potentiometer wire. One end of the potentiometer wire is A and another end of the potentiometer wire is C. So in a primary circuit, battery or cell B and rheostat and key and potentiometer wire, these are connected in series as shown in the figure. So this is primary circuit. And secondary circuit consisting of two cells. One cell is E1 and another cell is E2. So these two cells are, we are going to compare the EMF of these two cells. And this one is two-way key. Two-way key. Two-way key means we can connect any one of the two wires. So here you can find one terminal, it is represented by 1, and another terminal 2. And here 3. So if you connect 1 and 3, then the current flows through E1. Or otherwise, if you connect 2 and 3, then the current flows through E2. It's a two-way key. So we can use it in any one of the two ways. So it's a two-way key. And this is called galvanometer. So galvanometer shows the deflection and the current is flowing through the circuit. When no current flows through the circuit, then galvanometer does not show any deflection. It is a zero deflection. And this is a jockey. So we can move this jockey on the wire from A to C along the length of the wire. So this is the construction of the experiment. And working is, when the cell is on, then what happened? This is a positive terminal and this is a negative terminal of the cell. This is a positive electrode and this is the negative electrode. Now, when the cell is on, then what happens? Current flows through this one. So, depending on the two-way key position, the current flows either through E1 or through E2. So, for example, in the first case, if I connect 1 and 3, if I connect 1 and 3, then what happened? So, E1 to 1, 1 to 3, 3 to galvanometer. So it forms a closed circuit. So in that closed circuit, current flows. Then what about E2? So in this E2, these 1 and 3 is connected. So 2 and 3 are not connected. Then what happened? Here it is a disconnected. E2 is a disconnected here. So here current does not flow through the E2 when 1 and 3 are connected. So when 1 and 3 are connected, then the current flows from positive terminal to along E1 and 1 point to 3 point and galvanometer and this is J1 jockey position. So closed circuit. Now by changing the position of the jockey, so at a particular position galvanometer shows zero deflection. That is called balancing length of the potentiometer wire. So we have to move the jockey from A to C slowly on the potentiometer wire. So while moving the jockey on potentiometer wire at a particular position, the galvanometer shows zero deflection. So that position is called balancing length. So that length is directly proportional to the potential difference of this cell. The reason is, what is EMF? EMF is nothing but potential difference between positive and negative electrodes in a circuit when no current is flowing through the cell. So when the jockey is at this position, no current is flowing through the cell. The galvanometer is showing zero deflection. So the galvanometer is showing zero deflection means no current is flowing through the circuit. No current is flowing through the circuit means at that position the length of the wire is directly proportional to the potential difference of this cell according to definition and statement of potentiometer. So what is the statement of potentiometer? The potential difference across the length of the wire is directly proportional to its length. So the length is from point A to this jockey position length is, let us take L1. That is the length. Now at this position of the jockey, galvanometer is showing zero deflection. Means that is the definition, according to the definition of EMF. At that point, the potential difference of this cell is nothing but its EMF. So that is represented by E1. So according to statement of potentiometer, E1 is directly proportional to L1. So this is equation number 1. Now it is a two-way key. So just now we have connected 1 and 3 terminals. Now we are going to connect 2 and 3 terminals. So when you connect 2 and 3 terminals, then what happens? 1 and 3 is disconnected. So 1 and 3 is disconnected means no current flows through E1. And 2 and 3 are connected means current is flowing through E2 cell. Now to the galvanometer jockey position. Now when you vary the position of the jockey on the potentiometer wire at a particular position, the galvanometer shows zero deflection. So at that position, the EMF in the second cell is directly proportional to its length. So at when 1 and 3 are connected, at the balancing length, at the balancing point, the EMF of first cell is directly proportional to length L1. And when 2 and 3 are connected, at the balancing length of the jockey position, the EMF of second cell is directly proportional to its length L2. So this is equation number 2. Now equation 1 divided by 2, then E1 by E2 equals to L1 by L2. So this equation represents the comparison of EMFs of two cells, where E1 is the EMF of first cell and E2 is the EMF of second cell. L1 is the balancing length when the current is flowing through the E1, and similarly L2 is the length of the potentiometer wire at the balancing point when the current is flowing through the E2. So this is the E1 by E2 equals to L1 by L2. This equation represents the comparison of two EMFs. By measuring the lengths, we can calculate the E1 and E2, so that we can compare the EMFs of the given two cells. So thank you.